Hello everyone, I am Varun. I am one of the instructors for this course titled Fundamentals of Combustion for Propulsion. You would have already finished watching 2 weeks of lectures for this course, and you would have also, I hope, attempted to solve the assignments and turn it in. Uh, the purpose of this new video, which you will not find in the last year's version of the course, this is a new video. The purpose of this video is to provide you a bit of a background and introduction about the structure of the course and what topics will be covered in a particular week or a couple of weeks if there are connected topics. This decision to provide such videos is based on the feedback that we received from the batch of students, from the previous batch of students who took this course. They had indicated that some of the topics are new, probably a bit advanced than what they had expected, and there are also some exotic topics which are not usually dealt with in such detail in a regular combustion course or a propulsion course. The topic I am referring to is what you will see in starting from week 3, and a majority of it you will see it in week 4, deals with composite solid propellant combustion. And yes, it is a exotic topic and it's not very commonly taught in graduate level combustion courses in such detail, but there is a very specific reason why that is included in this course, and which is also something that I will talk about when you get to week number 3. Okay. Before I go into the details, let me give you some information which is already there in the portal. You would have noticed it, but I would like to go over it just to reinforce some of the points. The first thing I want to say is that this is a course called Fundamentals of Combustion for Propulsion. The emphasis is for the following reason: it is not just fundamentals of combustion and it is not just fundamentals of propulsion. It is fundamentals of combustion for propulsion, and that makes it a unique course in many ways. Okay. Now I would like to draw your attention to the fact that in the MOOC page of this course, you will find that the level of the course is this is a postgraduate course in mechanical / aerospace engineering, and it has a prerequisite. The prerequisite is that you have a UG or a PG degree in mechanical or aerospace engineering. So the target students are students who have already completed an undergraduate degree in mechanical or aerospace engineering or related fields, and somebody who is pursuing a postgraduate program, which could be an MTech or a Master of Science or a PhD program in mechanical or aerospace engineering, hoping to specialize in combustion and propulsion. Okay. I should also add this information, which we may have mentioned in the introductory video, that this course was recorded in front of a live audience. Okay. And the audience had members who were predominantly research students from IIT Madras and other research institutions. And another unique feature of this course is that the audience also had a few practicing engineers from defense research and the space research organization, that is DRDO and ISRO. Okay. And this unique combination of participants was actually created so that we could have an environment where research students can interact with practicing engineers and understand the kind of problems that are faced by developers of propulsion systems, so that they could orient their laboratory studies and research, which will, if not immediately, eventually help the practitioners develop better systems. Okay. And with this aim, the audience, the participants were identified, and about 20-25 people about 17 to 18 of them were research students, the rest were practicing engineers from various laboratories of DRDO and ISRO, participated in the course, lively discussions happened and a lot of exchange of ideas and so on and so forth. And it was decided at that point that a wider group of people, students interested in combustion research should benefit from this course, from these set of videos, and it is with that aim that we decided to convert this into a MOOC course, and the result of this is what you see as fundamentals of combustion for propulsion. Okay, of course some of these ideas, some of these things you would have already heard in the introductory video, in which myself along with Professor H.S. Mukunda gave an introduction for the course. Okay, with that background, I would like to go into a little bit of detail of the contents of the first 2 weeks of this course. Okay, so in week 1, okay, the topics that were discussed were, after a brief introduction of what fundamentals are needed for what fundamentals of combustion are needed for developing propulsion systems. After a brief introductory discussion on that topic, specific aspects of combustion processes in propulsion devices, including reciprocating internal combustion engines and gas turbine engines, were discussed at great length. These are propulsion systems which use air as an oxidizer. Following this, in the next lecture, you will see that combustion processes in propulsion devices or rocket propulsion devices, both solid propellant, using both solid propellants and liquid propellants were discussed. The difference between rockets and air breathing engines is that rockets carry their own oxidizers, they do not breathe air. Okay, and that is the basic difference. And following this, we got into a little bit of details of important fundamental processes in combustion which are relevant for propulsion. Okay, the first topic in this is the idea of equilibrium states, and how equilibrium states must be calculated. What are the fundamental equations needed for calculating the equilibrium states, and we also discussed a little bit about what tools are available which can enable people to easily calculate equilibrium states. Following this, there was a discussion of the next fundamental idea, which is chemical kinetics, which deals with the process, deals with the question of speed of chemical reactions. Equilibrium does not bother about the speed of a process, but on the other hand, chemical kinetics is a subject that deals with speed of processes, particularly of chemical reactions. And then the natural question that arises is, in an actual combustion system, how do we know if a process is closer to equilibrium or is controlled by chemical kinetics? And using some examples, this question is a very important question, which the understanding of which is crucial for evaluating designs of combustion chambers in propulsion systems, was discussed at some length. Okay, as you can see, these topics might appear advanced, but you need to keep in mind that, as I mentioned earlier, this is not a fundamentals of combustion course, not just a fundamentals of combustion course where each one of these topics will be discussed at great length. That is not what is done here. What is done here is only the essential ideas which are needed for you to think about real problems are discussed here. Okay, this is a key aspect that I hope you will appreciate and keep in mind when you are watching the lectures and solving assignment problems. We are trying to convey to you the key ideas, and through the assignments we are trying to reinforce these ideas through problem solving. Okay, and you can see right in the first week we have moved into topics which in a traditional combustion course might happen after 4 weeks or maybe after 6 weeks. We are already discussing about chemical kinetics, equilibrium, versus rate controlled processes with examples involving flames, actual flames. And in a combustion course, you are introduced to the idea of a flame much later, after the ideas of thermodynamics, chemical kinetics, transport phenomena are all introduced, conservation equations are derived, and only then the idea of flame is introduced in a traditional combustion course. But what you will see in this course is very different from all the traditional approach. Here, the flames are considered as fundamental entities in a combustion process, and all discussions, introduction of ideas, other ideas like or related ideas like thermodynamic equilibrium, chemical kinetics, and transport phenomena are all done in the context of analysis or constructing an analysis framework for the fundamental entities which are flames. And through this approach, you are taken right from the beginning into the core aspects of combustion processes in a propulsion systems, and we have done that with the hope that it will enable you to think about real systems. Okay, and this is the purpose of the week 1 lectures. Of course, week 2 is a continuation of the same theme as week 1, starting with a demonstration of a commonly used tool for calculating equilibrium states. Keep in mind that the numbers that are calculated, the flame temperature, the composition, the molecular weight of the combustion products, the speed of sound in the combustion products, and will be eventually related to a concept called characteristic velocity, which is a fundamental quantity, a fundamental design variable in design of rocket propulsion systems. Okay, and this is how ideas are connected, and perhaps what was missing in the original set of lectures is that these connections were not explicitly brought out because the audience were already familiar with it. And the reason, and that may not have been the case with a wider range of audience who have taken this course, and the purpose of this, one of the purposes of this video is to explicitly make those connections as to why some idea is introduced and how it is used later. This is one example of that. Okay, and once the idea of equilibrium and chemical kinetics are introduced and NASA CEA is demonstrated for calculating equilibrium states, we moved into a slightly further detailed study of premixed and diffusion flames. Premixed and diffusion flames, laminar premixed and diffusion flames represent two extreme but fundamental entities in combustion theory. Okay, and this is divided into two parts. First part discusses the premixed flames, the principal features and differences, the principal features of premixed flames. The second part discusses the principal features of diffusion flames and the difference between these two, the crucial differences between these two are also discussed. And as the title of the lecture itself will suggest, we are discussing principal features. Details come later. As long as you have understood the principal features and integrated that into your thinking process, details can always be added. Okay, so the aim of these two lectures is to bring to your attention, to add to your thinking process the principal features, and this is what you would have you were expected to have understood from the these two lectures on principal features and differences between premixed and diffusion flames. And then just for the sake of completeness, a lecture on quenching, flammability and other limit phenomena are introduced. These are important, but we need to also keep in mind that these are limiting phenomena which do play a role in design of propulsion systems, but in the first go, if you you did not get all of it, it's okay. You can come back and see it later when you need to. Okay, so I hope I have given you a good background for the reason why the structure, why the course in the first 2 weeks is structured somewhat differently from conventional propulsion courses or conventional combustion courses. I hope you will appreciate the purpose of this, and I also hope you enjoyed watching these lectures. And I suggest that with this new introductory video in place, please go back and review the lectures one more time and make sure you have made the connections and uh, in the context of the structure of this course. Okay, thank you.